Disclaimer: the following presentation is purely for educational purposes. Any patents connected to this project will not be infringed or used in the creation of a new product. As a member of the Georgia Tech Catholic Center, I have been trained in many different assisting roles for the Catholic Mass. One of those roles is altar serving, a very important job in the liturgy as we assist the priests throughout the service. Halfway through the Mass, one of our jobs is to kneel down and ring a bell, as I will now demonstrate. This is the bell that we use at the Catholic Center here on campus. It is rather heavy, and the sound it makes is very loud. The issue, however, comes in its grip. For being a very large bell, the grip is very uncomfortable in the hands. Here's another view of the bell being held in my hands while I ring it. As you can see, there is no clearly defined location for the hand to rest, which can lead to it being rather unwieldy, especially when grabbing it quickly during the prayers being recited by the priest. Also, the fact that the handle is purely brass can be an issue in and of itself, as when your hand is sweaty or loses grip, it's easier to drop. With these major issues, I have nearly dropped it on many occasions, and honestly, I would like to make sure that does not happen again. For this design project, I intend to modify this bell grip in two ways. First, I will make a more well-defined grip that fits the hand much better. Secondly, I will use a more comfortable gripping material to the outside of the grip so that us altar servers can use it more efficiently and with more confidence. Looking at the current bell handle, it is formed by connecting 3 bars towards the center of the bell's circle. This leads to the weird holding experience, as there's no clearly defined region for your hand to rest, while also making sure that the bell is being run correctly and efficiently. To remove this issue, I will remove this current setup and instead opt for a straight bar along the circle so that the bell can be held much more effectively and be supported better in the hand. Next, my plan to address the slippery grip is to use a grippier material such as wood around the grip to allow for the server to hold on better. Wood is a good material for this because it's cost effective and also is used in other altar server devices such as patents or candle lighters. Here is my final design for the new bell handle. As you can see, this new layout allows for a sturdier location for the altar server to hold onto the bell and control their motions. It's also less likely to give the user cramps or any other issues due to its more natural and comfortable design. The increased surface area by the wooden grip also gives the user nearly 12 square inches of surface area to hold onto in a comfortable manner. Looking at the designs side by side, it is clear that the redesigned handle looks much more comfortable and easier to use. Manufacturing this new bell design would not be terribly different from its current process. The handle will be manufactured separately and then welded together to form the final bell assembly. An important thing to point out is how there are 3 separate parts for the handle, 2 metal connection bars, and the wooden grip. This is because the wooden grip itself would be connected via a tang at the end of each of the 2 metal bars. Handbells such as the ones currently used at the Catholic Center are usually made by metal alloys such as brass and bronze and are manufactured via metal casting. The 2 metal bars would be made via the same process to ensure consistent manufacturing and size. The wooden grip would be created via woodworking, with processes such as planing, cutting, and sanding to get the flat sides and rounded edges that are comfortable for the user. Then the wooden piece would be connected to the tangs via a large gap in the wooden piece drilled out during manufacturing. It is the same process employed by tool manufacturers to create wooden handles on devices such as shovels or buckets, just completed for a different context. The end result is a secure handle made out of sturdy yet comfortable material for the altar server to hold onto during the Mass. There are many pros associated with this new bell grip design. The improved ergonomic experience with this improved grip cannot be overstated. This would make the altar server experience easier and less prone to mistakes. This is also supported by the grip being made out of wood instead of metal, which is an easier material to hold onto securely. The added control and comfort also ensures that the sound of the bell is clearer, as the user would not be focusing on the grip, but instead on simply ringing the bell. Finally, the design change is not visually distracting, as it still ensures that the bell still has a similar look to both the original bell design and to the other devices used by altar servers during the Mass. There are, however, some cons to this design change as well. The added complexity to the manufacturing of the grip by the inclusion of a wooden handle could make the bell more expensive. More material and extra manufacturing time increases cost of production for any object, including this bell. The manufacturer also has to be very cautious while welding, as the wooden material could burn while welding occurs. The added caution is another issue that leads to an increase in labor and costs. For the overall user experience, however, this new change is better in practically every way. In conclusion, while there can be some issues in the overall manufacturing process and costs, the benefit of this ergonomic design for the altar server bell handle at the Georgia Tech Catholic Center are huge for the individual ringing it. Thank you so much for watching.